Here we go in our last lesson on the chain rule. So we got trigonometry. Chain rule often shows up with trigonometry because you'll have a trig function with a function on the inside, right? So just to go over notation here, we're asked to differentiate each of the following. This notation, this is the same as saying the sine of 3x squared. So understanding that, now you see that the outer function is sine and the inner function is 3x squared. So to take the derivative, it's not so bad, but you got to know your trig derivatives, got to know those. The derivative of the outside is cosine. You leave everything on the inside the same. Right? So that's derivative of the outer function, cosine of stuff, if you will. So if it helps you to look at it as sine of stuff, you're essentially finding cosine of stuff times the derivative of that stuff. So derivative of the outside times the derivative of the inside. And the derivative of 3x squared is 6x. We rewrite that as 6x cosine of 3x squared. Never, ever multiply this by that because this is no longer a part of that angle. Right? So very, very important. That's it. Let's go on to this one. This requires us to rewrite it a little bit. I would rewrite this as cosecant x. You can either put the 1/2 right here. I like to put it out here because it makes the chain rule really pop. Right? So you've got dy dx, we're differentiating with respect to x, is equal to the derivative of the outer function is going to be the derivative of stuff to the 1/2. So that's 1/2 times cosecant x raised to the negative 1/2. So it's the derivative of the outer function times the derivative of the inner function is minus cosecant x cotangent x. Beautiful. So now from here, all we've got to do is simplify it down. So we used our chain rule, derivative of the outer times derivative of the inner. So we've got a negative 1/2. We've got cosecant x cotangent x. So I'm going to write that as negative 1, just kind of join the numerator together, times cosecant x cotan x. So I'm going to get rid of that 1, just write this, cosecant x cotangent x, all over cosecant x to the 1/2. Like so. Now, some people might recognize that these are the same and you can then subtract. I interrupt this part of the problem to tell you you should have the 1/2 still in the problem, so you should have a 2 in the denominator the rest of the way. Sorry about that, guys. Back to our regularly scheduled explanation. Minus cosecant to the 1/2 x, if you want to write it like that, cotangent x, and yet other teachers are going to want you to rewrite it as the square root of cosecant x, cotangent x. So you can go down to there if you really need to simplify it out that far, but the main idea is this. Notice that the chain rule is alive and well in both of these problems, and in this case, the inner function was the angle that we were taking sine of. In this case, cosecant was the inner function, but either way, the chain rule, the derivative of the outer times the derivative of the inner, is in play. Now, in every trig class, there's usually the double chain rule type problem. Sometimes people do a triple chain rule, which is crazy, but we'll go with what's most common. I've seen it on the A, B, and BC exams. I've seen it in almost every single calc class there is, where you have 2 chains. Not 1, but 2. Well, what's better than 1 chain rule, right? 2. So if we're taking the derivative with respect to x of this, before we do that, I think it's actually important that we rewrite this in a way that the chain rule becomes a little clearer. So this is really the derivative of cosine of 4x squared, all of that, raised to the 5th power, right? That is what this actually means. So now you see you've got 3 layers here. You've got your outer function, which is stuff to the 5th. You've got your inner function, like your middle function of cosine, and the innermost function is 4x squared. So we're going to unpeel this like layers of an onion, right? Beautiful. So the derivative of the outside is 5 times all of that. So 5 times everything on the inside, cosine of 4x squared, all raised to the 4th. So you took the derivative of the outside now. Now we need to take the derivative of the inside. So focus on this. We just need the derivative of the inside. That is your only problem right now. Well, that requires the chain rule too. The derivative of the inside is going to be minus sine of stuff. You're only focused on the inside. Don't worry about where you've been. So minus sine of stuff times the derivative of its inside, which is 8x. And then we'll join up everything. But before we do that, I want to just harp on the idea that this is not as bad as it looks. Don't think, where do I do the chain rule? Where does it end? Keep going until you've taken the derivative of the innermost function. So you're looking at this and you're saying the derivative of the outside is 5 times everything to the 4th. Then you're saying, okay, what's the derivative of the inside? And now your brain is only focused on this. And this is an old problem we've done earlier in this video. The derivative of that, just that, only focus on this, is minus sine of stuff times the derivative of its inside, 8x. And then you're done because you've taken the derivative of the innermost function. That's it. So keep your bearings on those. We're going to multiply everything. We've got minus 8 times 5 with the x is minus 40x. I'm going to keep the sign outside too. Why not? Sine of 4x squared. You can put that in parentheses if you want or not. Times, I'm going to put this fourth right here. Cosine of fourth of 4x squared. And that is all that problem wrote. Sick. Make sure you know how to do it. Watch it a few times if you need to. But think about it mentally along the lines of how I presented it. I'll see you in the exercises. Peace.